Hello everyone. Today we're going to talk about Kadena. Kadena is one blockchain that's being made with a very specific purpose in mind, which is usage by real-world businesses. In that manner, they are built to be scalable, highly efficient, secure, and this is the word secure because their language, Pact, which we use to build smart contracts, has been built essentially to be almost fail-proof. So it helps you build safe smart contracts, and this allows some of the pitfalls that you see in Ethereum, Solana, and other different blockchains. How does it do it? Essentially, the language is not Turing complete. What that means is it does not have all the operations that a normal computer has. You can't really do anything inside of the virtual machine, inside of smart contracts, but you can do a lot. And the fact that they restrict your freedom on what you can build allows them to really build way easier to implement applications and more secure applications and allow formal verification in a very easy way. So essentially, they're very worried about not making mistakes into smart contracts and only having fundamental logic inside of the contract and all else off-chain. Remember that this is mainly because they're aiming at a enterprise and business world, not necessarily at a decentralized DeFi ecosystem that we see on Ethereum and other networks. Since the language is very secure, once you learn how to use it properly, it's fairly simple to build smart contracts. But there are two very important things that Kadena has which make it difficult to use. The first is its multi-chain nature that I'm going to explain right now. And the second is formal verification, which is a way to check if the contract is doing what it is supposed to do, but not with regular tests, actually by proving with a mathematical background that the contract can never perform certain kinds of bugs, that it will always respect some kind of rules. So let's get to it. Multi-chain. This is the main difficult thing to grasp about Kadena. I'm going to explain first how it works on the protocol level and then how it impacts our smart contracts. So essentially, when you look at Kadena in traditional blockchains such as Ethereum or Bitcoin, they are very different. Ethereum and Bitcoin are one blockchain. So essentially, you have a sequence of blocks, one after the other, that is going to be minted with the transactions inside of them. Kadena is not like that. The way that Kadena scales using proof of work is by actually having a lot of different blockchains running in parallel and referencing each other for consensus. So essentially, they can be running thousands of blockchains in parallel as if it were a single one. And that's how they achieve their scale with proof of work. This is a genius way to scale a blockchain, but it generates a lot of difficulties when you're building your smart contracts. So the main thing here is essentially every account and every contract only exists in one of the chains at the same time, not in all of them. So when you develop your D app, you need to think about this. There are two main features here to have to keep in mind. One thing is you can build your app in a single chain and force everyone to bridge their assets over to interact with it. This works well, and you can kind of implement the same logic that you have in Ethereum or Bitcoin inside of Kadena. It's going to work fine. This works right now, and it's probably going to work for a long time into the network as it is. However, this means you're not going to be leveraging the benefits of the blockchain. Essentially, if you take a normal blockchain, it only has one place to go. Here you have thousands. So transactions can flow through thousands of different blockchains. But if you only put your application inside one of them, and this one gets clogged by whatever reason, your application is going to get expensive to run, it's going to get slow, and you're not going to get the performance benefits of the blockchain as a whole. So you need to build your app in a way that it can deploy to all different chains or to a lot of them through time, and the logic must work throughout them. You have to think about how you structure applications, for instance, a token. How can you ensure a maximum supply over all chains and not on a single one? If you talk about DeFi, how can you ensure that exchange rates are the same or at least similar between the different chains? You have to think about all of this. This is more on the logic level, but if you try to cut and paste contracts from Ethereum or Bitcoin, they might work because we still don't have a lot of volume on Kadena as of now. But as the network grows, you might have a lot of trouble and you might not be able to scale. So if you want to scale your application, you have to think in the Kadena way and not in the old single blockchain way. It's essentially the lesson here. The second point is formal verification. Kadena allows you to use this very powerful tool to test your smart contracts. So it's a mistake not to use them. Whenever we audit some code on Kadena, we're always going to look at those. And if the author did not build any of those tests, we're also going to build some to test the code. And why is that? In a traditional environment, you use tests. What are tests? Tests are a way for you to run code and essentially assert after the code has run that the state of the application is correct, that it has performed the correct modification into state. That means transfer the tokens to the right place or made the correct operations. That is very efficient and very important to understand if our app is working properly, but it has some problems. The main problem is when you test a specific scenario of execution. And there are a lot of different variables that you cannot predict. So cloud networks, maintenances, and other different ways in which people can interact with the application that you have not predicted might have different outcomes that are not the ones you expect. And you can never really find all of the outcomes beforehand. So it's important to find a way to do so if the application is very important in terms of money or if it holds a lot of assets. So it's always important to do something besides this testing. And formal verification is a way to do it. Formal verification is a way to actually get a mathematical proof, so it's 100% sure that something is impossible into your application. So how do you do it? Essentially, you could say, for instance, you could test if it is possible for someone to double spend their money into the app, if it's possible for the app to mint over 1 million coins, if it's possible for the app to do whatever it is. You have to formulate that as a mathematical statement, and you're going to be able to prove it or not. And this really is very powerful because it allows you to test all of the cases for a specific feature without having to write a lot of different tests. It's on a single statement. You do a formal proof and you get a response. This allows you to be very precise on your testing and quality assurance as a whole. So what's the mistake here? The mistake is not to use this. Kadena has made it very simple for people to use formal verification, especially when you compare that to traditional apps. Traditional apps take a lot of effort to do this. It depends a lot on the architecture of the language and other things that are not in the power of the programmer. And the way that Kadena is structured Pact, especially because it's Turing complete and has some other different features, it's very easy to do this. So it is a must. And whenever we look at the contract, we're going to be looking at those codes. If they're not present, we're going to be trying to build them as well to prove that the code works well. So these are the main 2 points of Kadena. The language is fairly simple to use. It allows people to build safe applications, but it's very important to look at the whole model of how the Kadena network works in terms of different blockchains and how to communicate between them and make sure that the state is congruent between all of the different layers. And also using formal verification to make absolute sure that your contract is doing what it is expected to be doing. If you have any other questions or want to know more about developing on Kadena, auditing on Kadena, please reach out to us. We are available in the chat here. We also have a Telegram on the link. Just reach out to us and we'll be able to talk a little more. Thanks for watching, guys, and see you next time.